Welcome to Study Loop.
Okay, so this question asks about writing a balanced equation in the basic aqueous solution. So just a glance look at those equations, you'll find they are all oxidation reduction reactions. So the easiest way to balance reaction is simply to find out the electron transfer. So now we can first look at the first one, which is hydrogen peroxide. And react with chlorine double oxide and forms a ClO2 minus and plus the oxygen. So let's look at what is electrons. So first, let's just look at the valence state. So in the hydrogen peroxide, the valence state of hydrogen oxide is -1. And for the chlorine double oxide, right, the valence state of chlorine is +4. And after reaction, you find that there's chlorine. Now it becomes how much? Actually, it becomes +3. So here, the chlorine are given electrons, as you see. So are getting electrons. So from chlorine to the chlorine oxide ion, it's gaining 1 electrons. And then you have oxygen. So definitely the oxygen are given electrons to form oxygen gas. So here you can see each oxygen atom will actually give 1 electrons to form the oxygen. So for each molecule, you actually give 2 electrons to this series. So now we can balance it, right? Because for every hydrogen peroxide, it gives 2 electrons. But for every one of the chlorine double oxide, it gets 1 electron. So the balance will just be 2. You have to balance, then the electron transfer will be the same. So now, and we can say, how can we actually balance it? So now we look at here for this part, they are balanced, right? The oxygen. And after release the oxygen, there are another 2 hydrogen left. So normally you should write down the hydrogen protons here, but it already says it's in the basic solution. It said it's in the basic solution. So it will definitely not form protons. So it actually will react with a hydrogen oxide. So it forms 2 moles of water. And that's how you balance the first equation. And the second one is you use aluminum reacts with the manganese oxide. It's minus. And then it forms manganese double oxide and aluminum hydroxide ions. So then let's see, aluminum has 0 valence state. And for this manganese oxide, what's the valence state? It's actually +7. And when it forms manganese double oxide, it becomes 4 plus. And when it becomes aluminum hydroxide ions, it becomes 3 plus. So you can see here, the manganese are gaining electrons, gaining 3 electrons for each one. And aluminum are also given 3 electrons. So you can say here it's actually already balanced since they have the same. Now what we need to do is just to actually balance other elements, right? So when it forms the manganese oxide, there will be another 2 oxygen left for the manganese oxide 4 minus. And here they used it has 4 oxygens, right, for aluminum, and 4 hydrogens. 4 hydrogen, 2 oxygen left, so there will be 2 waters here. So then that's how you balance it. And equation C, you have chlorine gas, and actually forms chloride and ClO minus. So this reaction is interesting because the chlorine acts as oxidant and also as reducing agent. So for this one, it has a -1 oxidation state. But for aluminum, O minus has a 2 oxidation state. For each chlorine, you say 2 when transforming this 2. So that's an easy way to do that. We can just write down the 2 chlorine gas. And this one from chlorine to this one, right? Each one will actually transfer 4 electrons. And from this to this one will actually give 2 electrons. So that's to say this you have to times 2, right? So that would be 4, and here is a 2, and then we can try to do the answer. It becomes 3 chlorine forms 4 chloride and 2 ClO minus. And what else you need? It says it's in the basic solution. So you have water. It should have actually OH minus, right? Now water, OH minus, and it gives 2 oxygens. So you should have 4 OH minus. And there will be 2 waters. And this is probably the answer. And that's it.